Hello, assalamu alaikum.
Ma-
Can you hear me?
Hello, Mr. Rahman.
Yeah. So how are you?
Salam alaikum. Can you hear me?
Yeah, I can hear you.
Well, alhamdulillah, alhamdulillah. Alhamdulillah, Rahman, Mr. Rahman.
Okay. Okay. Thank you for joining. So basically, today we try to discuss about the machine learning and how we can easily use the machine learning method to make the different types of land use, land cover classification, and all of those
Ah.
machine learning supervised and supervised, how it will be work, and different types of algorithm, random forest, support vector machine, then also decision trees. So this type of algorithm, how it will work. So I also try to show you that all of those things practically, one by one. So we try to complete the theory part as well as we also try to show you the practical part. Okay. So did you get the previous class, recorded video class? Did you get it?
Yeah, I got it, Mr.
Okay.
Rahman.
Okay. So let's. Okay, so basically you enroll our total 15 days online training program and we already cover our first day and second days. So basically today is the third day and mainly today I try to discuss about that land use land cover classification using machine learning method, how we can easily implement that. So all of those things we try to complete from the beginners to advanced level. Okay, so let's go. So not first day, it was third day's online training program for the land use land cover classification. So basically, first of all, I try to discuss about the land use and land cover, and what's the technique for the land use land cover classification using remote sensing. Then land use land cover process using remote sensing. How many process we can make the land use land cover classification map, and then we move to the machine learning. So we try to discuss some about the machine learning, then machine learning method, then machine learning classification, then what is the supervised classification, then we talk about the support vector machine, okay, as well as also support vector machine classification argument, and then support vector machine type, and then popular kernel of support vector machine. So basically there is a lot of kernel, we try to discuss step by step. Then gamma, what is the gamma, then cost function, then practical example of support vector machine using land use land cover classification. Okay. And then practical example of support vector machine for identifying the deforestation. Okay, how we can easily identify for the forest and deforestation for any specific region using the support vector machine algorithm. Okay,
Yeah, okay.
and then how to create the
Mr. Rahman,
single layer land use land cover map. Yeah, please.
what about unsupervised classification?
Yeah, we also try to cover that. All of those things we try to cover,
Okay.
supervised and supervised, and all of those technique. Okay, basically land use, land cover, and change detection. It's a total 3 days class only for the land use, land cover classification with change detection. Okay, so we try to need for the 3 days for this specific topic. Okay, for the 3 days. Okay, and we start from the beginners to advanced level. So that's why I include all of those things step by step. Okay, so let's go. So first of all, land use and land cover. So mainly land cover represent the physical condition of the earth surface, such as forest, grassland, suppose hilly region. Okay, so it's a natural feature. And land use reflect the man-made activities, suppose settlement. It can be agricultural land. It also including the land use. Okay, as well as also for that pond, okay, or lake. So it is a land use reflect the man-made activities, including use of land, and land cover. It represented the physical condition. It mainly the natural feature, such as forest, ocean, river, grassland, this type of feature. And land use indicate the employment of the land by human. So we use the remote sensing technique for land use land cover classification. Okay. So basically remote sensing technique are the most practical and most efficient and provide the satellite data beyond human vision. And remote sensing provide the multi-spectral and multi-temporal two types images we can for get the accurate mapping. As well as land use land cover process using remote sensing. So first of all, you have to according the satellite images. Okay, it can be Landsat or Sentinel, anyone. You can acquire the satellite images, any sources. Just first of all, you need to acquiring the satellite images, and then it should be corrected both radiometrically or geometrically. Okay, you need to correction the images radiometrically or geometrically. But when you use the Google Earth Engine platform, you don't need to any types of correction because it already corrected all of those things. Okay, so in this time, suppose you want to download the satellite images, different sources without Google Earth Engine platform, then you have to apply the radiometrically or geometrically correction for getting the preferred satellite images. And machine learning for develop this model, you need to use the machine learning to develop your model. You can use the supervised, unsupervised, anyone, no problem. And then what is the machine learning? So mainly machine learning is a branch of artificial intelligence. Okay, so it is a branch of artificial intelligence, and mainly it computer science, which is the focus on the use of data and algorithm to imitate the way that human learn, gradually improving its accuracy. Okay, and machine learning method, basically we are using here the supervised machine learning method, unsupervised machine learning method, then also reinforcement machine learning method, but basically popular supervised and unsupervised machine learning method. And here you can see the classification about the supervised and unsupervised classification. So mainly what is the supervised? So when you want to do the supervised classification algorithm, first of all you have to need the pre-categorized data. Okay, so pre-categorized data, what is the pre-categorized data? Pre-categorized data means that I take the data. Suppose I want to classify land use, land cover for water body, build-up area, settlement, and then suppose grassland, cropland. So first of all, I need to take the training point for water body, build-up area, settlement, then cropland. All of those feature classes, I need to take the training point. So this type of training point called the pre-categorized data. I predefine this is the water, this is the urban, this is the build-up area. Okay, but unsupervised learning, you don't need to take any types of pre-categorized data. Okay, you don't need to take any types of suppose you did not classify this is the water body, this is the vegetation, this is the pond or lake. You did not types any types of training point, you did not include in here for the unsupervised learning. So unsupervised learning, we did not take any types of training data, but supervised learning, we can take must training data. Without training data, we cannot perform the supervised learning method. Okay, and we can do the supervised learning. You can see we are use mainly supervised learning for classification and also use for the regression. So now what is the classification? Classification mainly land use land cover classification. We classified the different types of land use land cover. And what is the regression? Regression mainly it forecasting. Suppose what is the weather for tomorrow? It's forecasting. Okay, regression mainly it is the forecasting, and classification means that it's mainly identify anything, any object or anything it can be identify, or feature class it identify. And regression is the predict. Suppose it can be predict anything, and for the prediction it need the some data. Okay, this data come from the pre-categorized data. Okay, and using this pre-categorized data, they can easily get the idea what's the happened on the future or tomorrow. Suppose for the past 10 years weather condition or temperature, we can easily find out the regression and can talk about the for the future or tomorrow. What is that for the tomorrow weather condition? We can easily say that it's a regression. Okay, and we can use the prediction and predictive model, use the supervised machine learning method. So supervised machine learning model mainly provide the classification and also use here the regression. Okay, and unsupervised learning. Okay, so mainly unsupervised learning, it also working for the three way. One is the clustering, then association, and dimensionality reduction. Okay, but in this time we just talk about the clustering, this part. For basically in this time we can just make the clustering. And what is the clustering? So mainly clustering, it's an unsupervised machine learning method, and using this method, we can classify a specific land use land cover classification without taking any types of training point. In this time for unsupervised, I did not take any types of training point. So now how they work? So unsupervised learning for the clustering is a method of the clustering. So first of all, it find out the similarity. Okay, suppose all of those water pixel value have a similar spectral signature. Okay, all of those urban, all of those vegetation, so has a similar or similar characteristics. So that similar characteristics make the group and make the classification without training any types of ground truth data or training point data. Okay, so clustering is very popular because when you want to make the land use land cover classification map using the unsupervised machine learning, you don't need to go to the visit physically. You don't need to go to the visit physically, or also you did not suppose you want to make the land use land cover classification map for a region. You don't know what's the region have, how many class for the region have. You don't know totally no information for your region of interest. Then you can easily use the unsupervised machine learning, mainly clustering. This method, all of the similarity pixel value collect and make the group and make the classification. Okay, so basically it defend the pattern and structure recognition. So it suppose all of those water pixel value has a specific pattern, all of those urban pixel value has a specific pattern. So mainly it's maintain the pattern and make the classification or recognition about the unsupervised learning. Okay, so basically this is basic difference between the supervised and unsupervised machine learning method. So first of all, now we talk about the supervised machine learning method more. So mainly in Google Earth Engine platform, we can use the supervised machine learning method, and it has some classifier. So in Google Earth Engine platform, the classifier has some package handle the supervised classification by traditional machine learning algorithm running in Earth Engine. So in this time, this type of supervised machine learning algorithm can be CART. CART means that classification and regression trees, random forest, then support vector machine. So this type of classifier. So basically CART is a supervised classification algorithm. Random forest is a supervised classification algorithm. Navy Bayes is a supervised algorithm. Support vector machine, all of those things is that supervised machine learning method. And Google Earth Engine platform, we can use it as a classifier, as a package. So CART, it has its own package. Random forest has its own package. So all of this classifier has a individual package. So in Google Earth Engine platform, we just simply use this package and make the classification, as well as we can also do regression. So now what is the general workflow for classification is, so first of all, collect the training point. You have to collect the training point because it's a supervised machine learning method. So supervised machine learning method, you must take the training point. Without training point, we did not take any types of supervised machine learning method. So supervised machine learning method, first condition, collect training data or training point. Okay, and then we have to set the classifier. We simply set the classifier. Okay, this classifier can be support vector machine or random forest or classification or regression trees, minimum distance, anyone you can use for your project work. So it depends on your project work. Okay, so when I talk about all of those classifier, random forest, then support vector machine, also talk about that classification trees, then you can easily get the idea which classifier is best for your own project work, for your own land use land cover classification map, which project work, which machine learning algorithm is best. Okay, so in this time, first step, collecting the training point, then apply the classifier, set the classifier. It can be anyone. Okay, then train the classifier using the training data. Okay, so this classifier, suppose you can take the support vector machine. So now this support vector machine, you need to train using your training data. After that, classify an image or feature collection, and then estimate the classification error with independent validation data. So this is the workflow for that classification when you do using the supervised machine learning method. And now we talk about the support vector machine classifier. So support vector machine is a classifier, and mainly this classifier is a supervised machine learning method. Okay, support vector machine mainly follow the supervised machine learning method. So now support vector machine, how it will be work and what is the main purpose of the support vector machine. So first of all, support vector machine is one of the most popular supervised learning algorithm, and it used for classification as well as also regression. So classification means that it classifies different types of classes, and regression means that it mainly predict the future using the support vector machine. We can also predict the future. As well as support vector machine is one of the most popular. It used for the classification and regression trees, and it used to classification problem in machine learning. And what is the goal about the support vector machine algorithm? So this algorithm create the baseline or decision boundary that can segregate n-dimensional space into class, so that we can easily put the new data point in the correct category in the future. And the base decision boundary is called the hyperplane. Okay, so support vector machine, its main target is that to create the baseline, and this baseline called the decision boundary. So it create the best decision boundary then that can segregate n-dimensional space into classes, so we can easily put the new data point in the correct category in the future. And the best decision boundary is called the hyperplane. And support vector machine choose the extreme point or vector. Okay, in this time, this point or vectors we can say as a pixel. So in this time, we can talk about the raster image. So that's why in this time it will be these points or vector we can say about that pixel that help in the creating the hyperplane, and this extreme case are called the support vector. Okay, hence algorithm is termed as a support vector machine. So in this time we take the example about that. You can see in this time here you can see first of all you can see this type of, suppose it's a pixel value of the vegetation. Suppose this is the green pixel value for the vegetation, and this blue pixel value for that water pixel value. Okay, and it's a decision boundary line. Okay, it's called the decision boundary line. And now this type of pixel value which is close to the decision boundary, it's called the support vectors. Okay, so it's a support vector, it's another support vector. Okay, and it's called the maximum margin. It's called the maximum margin, and it's the negative hyperplane, it is a positive hyperplane, and this boundary called the maximum margin hyperplane. So in this time, how it will be work for the support vector machine? Suppose in this time I have a two data set. Two data set means that I have a two pixel value, suppose green and water. Okay, vegetation and water. So when I apply the support vector machine, then it calculated the distance between this point. Suppose this it's a support vector, this point to distance to the decision boundary, which is connect with that. You can see which is the near by the margin, maximum margin. It consider this is the green pixel value. If it will be just connect with that small distance with this support vector, then it will be considered as a water pixel value. Okay, so also take the more example. In this time, support vector machine can be two types. We can get the two types of support vector machine. One is called the linear support vector machine, another is the non-linear support vector machine. Okay, so linear, mainly we can get the this type, it's called the linear. You can see it's a linear because you can get the totally straight line in here. It's linear. And linear support vector machine for linearly separable data, which means if a dataset can be classified into two classes by using a single straight line. Suppose in this time you have two classes, right? Suppose you want to make the classification only for the forest and deforestation. So forest is one class, deforestation is another class. So it is a two class. So for that, we can use here the linear support vector machine. Suppose you want to make the land use land cover classification map for the forest and deforestation region. So that's why we can easily use the linear, because if a data set can be classified into two classes using a single straight line, then we are using here the linear support vector machine. So it's called the linear support vector machine. And what is a non-linear? Non-linear support vector used for non-linearly separate data, which means a data set cannot be classified by using a straight line. Okay, suppose a data set I cannot be classified using a straight line. We have to use here the not a straight line. We use here that is the non-linear line we need to data and classify use it the non-linear classification. So basically in Google Earth Engine platform, we use here the linear support vector machine as well as a non-linear. But linear is the very work well for that, because in this time we can just use here the two data set, two classes. Okay, so suppose any project work you need to classify only for the two classes, just use here the linear support vector machine. Okay, just use the linear support vector machine, because linear support vector machine is the work well for that two classes of data. We can easily make a single straight line and then we can classify it. It's a water, it's a vegetation. It is a forest, it's a non-forest or deforestation. In this time here you can see, here I can get this type of support vector. You can see it's one kind of the, it's green, and suppose it's a water. Okay, it's the vegetation is a water, and it's called the decision boundary. Okay, and it's the maximized margin. Okay, and it's called the support vector. It's a support vector about that. Okay, support vector. Mainly support vector is the near. Near means that a distance. You can see this is the boundary. For this boundary is the near to this boundary. Okay, also it's near to the boundary. So for this data set, it will be support vector. It's not support vector, because you can see this distance, this blue color point distance, and this boundary, this line distance is close than this point. So that's why it's a support vector. Okay, it's not a support vector, it's not a support vector, it's a support vector, because this point is close to the distance boundary. Okay, decision boundary close. So it's a support vector. So now it's a lot of application for that. So the support vector machine algorithm help you to find out the best line or decision boundary. This best boundary or region is called the hyperplane. Okay, and support vector machine algorithm find the closest point of the lines from the both classes, and this point called the support vector. Okay, this type of point called the support vector, because it is the closest. Okay, and the distance between the vector and the hyperplane, is called the margin. Okay, so this distance called the margin, and the goal of the support vector machine is to maximize the margin, the hyperplane with the maximum margin called the optimal hyperplane. Okay, it's the goal of the support vector machine to get the maximize this margin. Okay, and when I get the maximized margin, it's called the optimal hyperplane. And it's some argument. Okay, suppose argument means that some keyword and key value for the support vector machine. First of all, decision procedure, then support vector machine type, then kernel type, then shrinking, then degree, then gamma, then cost, then NU. Okay, basically this type of argument we can easily get the Google Earth Engine classifier as a package. So this type of package including in this argument in Google Earth Engine platform, we can easily use this type of package and make the supervised machine learning method, mainly support vector machine. So this is the argument for the support vector machine. In this time, support vector machine algorithm, first of all, you can see decision procedure. So what is the decision procedure? Decision procedure to use for the classification. Decision procedure can be voting or margin. Okay, margin, we already discussed about the margin. We can see in this next previous slide, margin. So maximized margin. Okay, this is a maximum margin. So decision procedure is that voting or maximum margin. So basically we are using here the margin for that get the better result for the decision margin. And then support vector type, there's a lot of type. So one of the, you can see different types, one class, ellipson, NU, SVR. So these are different types of support vector machine. And kernel type. So one of linear, when you can use the linear, you can see one of linear. So basically it's different types of equation. You can see poly, RBF, sigmoid. So this type of type, kernel type we use in here. But popular is the RBF. Okay. So we are using here the RBF, and this is the equation about the RBF. And RBF, it's popular kernel. It's called the radial basis function. Okay. RBF, radial basis function. So popular kernels also you can see polynomial kernel, Gaussian kernel, radial basis function. Okay, so different segment kernel. Okay, different types of kernel. Okay, so you can in this time radial basis function is the best algorithm. So for that we are using the radial basis function, but there's a lot of work for the polynomial kernel, also sigmoid kernel, NOV RBF kernel. Okay, we are using the radial basis function and how it will work. So mainly polynomial kernel, you can see in machine learning, the polynomial kernel is the kernel function commonly used with the support vector machine and other kernelized model that represent the similarity of the vector, mainly training sample, in a feature space about the polynomial of the original values. And it's mainly allowing the learning of nonlinear model. So it's the mainly polynomial kernel model is mainly work for the nonlinear model. And radial basis function, it is the RBF kernel. It's the radial basis function. It's most generally from the kernelization and is one of the most widely used. Okay, for this kernel. Okay, it is similar. Basically, it is similar with the Gaussian distribution. And RBF kernel function for the 2 points. Suppose x1 and x2. These 2 points compute the similarity and how close they are to each other. Okay, between the decision boundary, how to close to x point and x2 point. And this kernel can be mathematically represented as a follow. Okay, this is the function follow about the, it's the represented of the kernel, RBF kernel. Okay, so x1 and x2, it's mainly compute the similarity and how close they are to each other. Okay, so this is the formula about that radial basis function kernel. And here you can see sigma is the variance and our hyperparameter, sigma is the variance, and x1, x2 is the Euclidean distance between the 2 points. And gamma, what is the gamma? Gamma can two type, then high gamma and low gamma. So gamma in this time, suppose this type of pixel value and also this type of pixel value. When the distance is low, you can see this distance is the low, it's called the high gamma. Okay, suppose distance means that support vector distance. This is the support vector, also it's support vector. When this support vector distance is low from the decision boundary, it's called the high gamma. And when the distance is, you can see long distance, in this time we can get the long distance, it's called the low gamma. So gamma can be two types. It's mainly make the calculate the distance from the sample. Okay, when the distance is the low, then we can get the high gamma. When the distance is the high, you can get the low gamma. Okay, that's opposite. In this time, this is the function about called the cost function. Okay, this is the formula about the cost function. In this time, this type of long equation, we did not memorize anything. We are just use here the package, classifier package. And in this package, all of those function, all of those things already including in here. We are just use here the package. Just we can cost function, what is the value? What is the theta value? We can simply mention that. Then it will be work. Directly this equation is the work. Just we can simply define what is the theta value. And theta value is the cost function. And in this time for the, how it will be work. So for that, this equation is the need. Otherwise, it's not need because it's the all of those things already created as a library or package. Okay. So in this time, practical example of using the support vector machine. So basically, support vector machine we are used as a classifier, and it's a popular supervised machine learning method. And in this time here you can see we can classify two types of class. One is that forest region and another is the deforestation region. You can see it is a deforestation and is a forest. And here you use at the kernel type is the radial basis function RBF. Gamma, we have put here the gamma distance 0.5. Okay, it's a sample distance with the your decision boundary. And cost, what is the theta? We can use that the theta value is the 10. And this is my classifier, and it's the support vector machine classifier. So using the kernel type radial basis function, use the gamma 0.5 and use the cos theta is the 10 degree. Then I simply make this classifier. So now this classifier I need to train with my training sample. So for this example, we take the training sample for forest region and also take the training point for the non-forest region. Okay, forest and deforestation. We take the two sample from that and then classify it. And it, when I classified using that, it automatically predicted. Suppose automatically predicted this is the deforestation region, it's forestation region. So other place, what is the condition? It automatically predicted. Okay, and support vector machine is very work well when I work only for the two classes. Suppose I need to classify only for the water body and build up. I can easily use that the support vector machine. I need to classify only for that forest and deforestation. We can easily use the support vector machine. Okay. Okay, so you can any question about the support vector machine, you can ask me. Any question or any comment, you can ask me. Okay, any question in here? Or any doubt?
It's fine, Mr. Rahman.
Oh, okay, okay. So I also send you all of this PDF reference book, as well as also send you the this type of slide which I already created. So you also try to read 1 or 2 times. Then you can easily get the idea how it will be work. And basically in this time, it's just a package. Okay, so Google Earth Engine has they already created this type of package. You can see the support vector machine. It's this package is already created. So in this time, we just need to simply input all of those things. Then we can easily get the result. Because it's a package, classifier.lib support vector machine. So it's a package. So this package has include all of those things, kernel type, gamma, cost. So basically this 3 argument, when I put in here, then it automatically create the land use land cover classification map about that result. Okay. So this is the one way for the support vector machine. And next we talk about the another algorithm. So I simply go to in here. Okay, so in this time we talk about the classification and regression trees and how it will be work for the classification and regression trees. So this is the another algorithm for supervised machine learning. Okay, after the support vector machine, we talk about the CART model. CART mainly classification and regression trees. So it is another algorithm for the machine learning, mainly supervised machine learning. And now we talk about that how it will be work and how to make the classification and regression. So CART is a predictive algorithm. It is a predictive algorithm used in machine learning, and it mainly explains how target variables values can be predicted based on the other values. Okay, I want to target a variable, so for that can be predicted based on the other values, and it is a decision tree. Okay, so classification and regression trees, it has the common thing is the decision tree. So what is the decision tree? Decision tree mainly here we can get some and the tree like shape. Suppose I can take the pixel and then check it is a water or not. Okay, so you can see in this it is a decision tree where is frog of split a predictor variable and is node. And what is the node? Node mainly is the final output from the decision tree at the end of the prediction for the target values. And CART algorithm is an important decision tree algorithm, and that lies the foundation of the machine learning. Okay, so CART algorithm, it is the foundation of the machine learning, and moreover it is also basis for the other powerful machine learning algorithm like decision trees, random forest. So decision tree, random forest, boosted decision tree, this type of algorithm also depend on the CART algorithm. Okay, so in this time, what is the decision tree? So CART for short term is that introduced by Leo Bremen to refer to decision tree. It is a short form term. algorithm that can be used for classification and regression predictive modeling problems. And the CART algorithm provides a foundation for important algorithms such as decision tree, random forest, and boosted decision tree. It is the foundation of the other algorithm. And CART model representation. So mainly here you can see CART model is a binary tree. Okay, so binary tree means that in this time here I can get the two types of data. So binary, suppose yes or no. Suppose you can think about that height greater than 180 centimeter. If it the yes, suppose it is a male, or if it is a no, then it check the another condition. Suppose weight greater than 80 kg. If the weight greater than 80 kg, when I can get the answer yes, then it will be male, or no, then I can get the female. Okay, so it is a binary. You can see we can get the two types of result. Two, suppose yes and no. So if the height is the 80, you can say height greater than 800 centimeter, then if it will be yes, then I can get the result male. And if it's not yes, then I check the another condition, weight. So weight greater than 80 kg. Okay, and then it will check yes or no. Then I can get the result yes, it will, or no, then female. Okay, for the male, what is the condition? For the male, this condition is for the male, height greater than 180 centimeter and weight greater than 80 kg. Then it will be male. Otherwise, it will be female. Okay, so now you can see the question about that. You can see this is my chart, and from this algorithm, suppose it is a decision tree. From this tree, I need to make a decision. It will be male or female. So you can see about that. If the height greater than 180 centimeter, then male. Then I can get the result male. And if the height greater than equal 800 centimeter and weight greater than 80 kg, then male. Okay. And if the height you can see the greater than less than equal 800 centimeter and weight is the less than equal 80 kg, then female. So now what is the question? In this time, I give a input height 160 centimeter and weight 65 kg. So now using this algorithm, you need to find out it is a male or female. Okay, can you guess the get the idea about that? You can see the result. Suppose you can see it is a decision tree. So now using this decision tree, I just input the new data. Suppose height 160 centimeter and weight 65 kg. So now from here, from these two condition, I input in my tree and then check it will be male or female.
Okay.
Can you, in this time you can see here, it's showing the height. Height is the 160 centimeter. So 160 centimeter is means that in this time I can get the no. Okay. So if the height greater than 160, then I can get the yes. Okay. So in this time height is the 160 centimeters means that I can get the no result. And I will check the weight 65 kg. You can see weight will be greater than 80 kg, but in this time we can get the 65 kg. So that's why it also no. So that's why using this data, supposed to weight height is the 160 centimeter and weight is the 65 kg. Then when I input this data in this decision tree, then it make a decision it will be female, because you can see height is the 180 kg, 180 centimeter. I can get the no, as well as weight 80 kg. I can also get the about the no. Okay, so when I can get the no result, two of things, then it will be female. Okay, so it's a model. It will be just when I want to use the CART model or classification regression trees model, then it will be work using the same way or same approach it will follow. So in this time here you can see the classification using CART model. So first of all, you can see this is the chart about that. Suppose you can see it is a green. Okay, G for green, and it's the red. Okay, so here I put a pixel value, suppose 0.3, okay, 0.3, and also 0.4. Here I put the 0.4, and it is 0.3, it is 0.4. Okay, so now using this algorithm, I need to use a decision tree. I need to make a decision tree, and using the decision tree, I need to find out what is the class. Suppose you can see that suppose the green, it is a vegetation. Suppose the blue, it is a water, and the red is that build up area. Okay, so in this time, suppose I put the decision R rate greater than 0.4. Okay, so R greater than 0.4 means all of those pixel value, okay, you can see greater than 0.4 means that all of those pixel value are greater than 0.4. So now what is the condition? If R greater than 0.4, it's yes or no. We can get the two type of result. When it will be yes, then I can get the building. Okay, suppose in this time 0.4 greater than 0.4, here I can get the red pixel value. So red pixel value is definitely, I can already say red is the building. Okay, and if there is a no, then it also check the another condition. If there is a no, it's a vegetation. Suppose I talk about the vegetation. Okay, so now it also check about the vegetation condition. Okay, so vegetation condition 0.3 green, 0. Greater than, you can see greater than 0.3 means this type of pixel value, it's a vegetation. Okay, so when I can get the green pixel value greater than 0.3, then it will be vegetation. So now we can see it will be yes, then it will be vegetation. We can get the vegetation yes, or when I can get the no, then it will check the another condition. Suppose then it check about that water. Suppose in this time it is the water, you can see water. So now we can use this algorithm. We can see we can use here the different types of decision tree. Okay, we can make the decision tree or binary tree, and from that we can easily get the result about that. Okay, so it's called the decision tree, and decision tree has a node. What is the node? Node is the final output. In this time, building is a final output. You can see in this time there is a no binary type. In this time we can get the building. Okay, also you can see the vegetation is a binary type. Also you can see water is a binary. So in this time vegetation is a final node. Okay, final node called that final output. It's a node. Okay, so it is a model about that classification trees. It's mainly work for that using this way. And it has also some algorithms such as max node. Okay, max node means that the maximum number of leaf node. Okay, if the is tree and unspecified, there is a no limit, and mean leaf population is that only create the node with training set contents at the list this many point. So now we can see here what is the leaf node. Leaf node is that you can see leaf node. It's called the leaf node. Leaf node. Leaf node. Leaf node. Leaf node. Leaf node. Leaf node means that final output. You can see it's the final output. Okay, so there is the node types of the tree in here. So it's called the leaf node. It's also called the leaf node. It's also leaf node, and it's the root node. Okay, it will be start from here, so it's the root node. Then we can simply take the decision tree, decision node. It's a decision node, and when it is a sub tree, okay, it is a sub tree about that. And when I can get the final output, it's called the leaf node. Okay, so leaf node, there is the no branch. You can see there is a no branch about the leaf node. Leaf node, there is the no branch. Okay, so it's called the leaf node. And here, how many leaf node? Total 1, 2, 3, 4, 5. 5 leaf node. Okay, and in this time you can see max node is that the maximum number of leaf node in each tree. Okay, each tree maximum number of leaf node. So in this time, in this decision tree, we can get the total 1, 2, 3, 4, 5. 5 leaf node. Okay, so now, okay, so basically it look like that way for that classification and decision trees. Okay, so now we talk about another thing is the random forest. Okay, so basically the three popular algorithm for the supervision machine, random forest, and classification trees. So in this time we talk about the random forest and how it will be work. So let's go. And first of all, random forest. Random forest is a supervised machine learning model algorithm. Okay, and random forest is a classifier that contains a number of decision tree. Okay, so decision tree is a number of contains a number of decision tree. Okay, and also can see the what is the decision tree. I already discussed in here in this slide. So you can see decision node. Okay, so it's a decision node or decision tree. Okay, 1, 2, 3. You can get the total 3 tree. Okay, or sub tree. So it's called the decision tree. So in this time for that random forest, For the random forest, we contains a number of decision tree on very subset or subtree of the given data set and takes the average to improve the predictive accuracy of the data set. And the forest builds a assemble of decision tree, usually the trained with the bagging method. And the general idea of the bagging method is that combination of the learning model in increasing the overall result. And how does the random forest algorithm work? So mainly random forest work in the two phase. First is to create the random forest by combining n-dimensional tree, and second is to make the prediction for each tree created in the first phase. Okay, so random forest mainly work for the two phase. First of all, it create the random forest by the combining n-dimension tree, and second is that it make the prediction for each tree created in the first phase. So in this time, we can see first step, it select the random. Suppose random, it create the totally random, suppose n dimension tree or point or training set. And after that, build the decision tree associate with the selected data points or subset and choose the number of decision tree that you want to build, and then repeat step 1 and 2 and then continue. Okay. And finally, for the new data points, find the prediction of the each decision tree and assign the new data point to the category that wins the majority votes. Okay. So what is the majority vote we can get in here? It will be selective. It is this class. So in this time, you can see example about that. Suppose you can see, suppose in this time here we can get some fruit. You can see different types of fruit we can get in here. So from this fruit, we can take some, you can see tree. So it is a sub tree, 1, 2, 3. Okay. So we created the total 3 sub tree. Okay. Suppose fruit, first tree I can get the apple, second tree I can get the apple, and third tree I can get that banana. And it's you can see n number of tree. So first step, random forest work for the two phase. First phase, it create this type of decision tree, n number of decision trees. Okay, so n number of decision tree it created. And second phase, it create this type of class. You can see, suppose first tree, here I can get the final node is the apple. Second tree I can got the final node also apple, and a third tree I can get the banana. So now apple, 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 I can get the 2 time apple and 1 time banana. So now what is the majority voting? Majority voting is the apple, so that my final class will be apple. Okay, suppose in this time here I can get the suppose water pixel value, and build up pixel value 1 time. 1 time I can get the build up pixel value. So majority voting, I can get the result for water pixel or water class. Okay, so it will work look like this, and we can also see another example. And there is a lot of application for the random forest, such as banking. We have also medicine and land use, land cover classification. Then marketing trend can be identified using this algorithm. Okay, and advantage of the random forest. There's a lot of advantage because we can use for the classification and also use for the regression tasks for that, as well as it's capable handling the large data set. Or basically random forest can be handling the suppose you want to make the lot of classes. Suppose you want to make the classes for water body, build up, vegetation, cropland, agricultural land. Suppose more than 6 classes or 5 classes, then we can easily use here the random forest. Okay, and it's capable of handling the large data set. Okay, with high dimensionality we can easily use it. So for that, you can see the maximum paper in the land use land cover paper that use here the random forest, because when you want to make the land use land cover classification with lot of classes, suppose more than 5 class or 6 class you want to classify it, then random forest is the best, because it is capable of handling large data set with the high dimensionality, and it enhances the accuracy of the model and also prevents the overfitting issue. Okay, so that's why it's very we can, when you use the random forest, we can get the very better accuracy than card or supported vector machine or card. We can get the better accuracy when you use the random forest algorithm. So in this time, you can get the practical example. Suppose in this time, a new pixel value, I want to classify it. I don't know what is the pixel value for that. Suppose I want to find out the new pixel value. What's the class about the new pixel value? So first of all, I make the decision tree. Suppose I make a decision tree, and finally I can get the another decision tree. Suppose another decision tree. So in this time, 1, 2, 3. I take total 3 numbers of decision tree. And first of all, I can get the vegetation. Second, I also get the water. And third, I can get the vegetation. So now for the random forest, here I can get the majority voting. So majority voting will be vegetation. So my new pixel value will be vegetation. So this is my final output or final result. So mainly decision tree work look like this way. So first of all, it creates the decision tree n dimensional, and then from that it takes the output, and from this output, which output is the majority, it takes the new pixel value. Okay, this is the pixel value about that. So now in this time we can see the some argument also random forest. One is the number of trees, number of decision trees to create. Okay, so in this time we can see number of decision trees to create. So in this time, this algorithm, you can suppose in this time there are the total 3 decision tree. So number of decision tree for this algorithm, this value will be 3, because I use here the total 3 decision tree and get this type of result. So and in this time, number of decision tree, the number of decision tree. So this is the one kind of argument in Google Earth Engine. Okay, for the support with random forest, number of trees. And then that's the suggested, the random forest should have a number of trees between 64 to 180 trees. Okay, so there are a lot of journal or lot of paper, they mention about the number 64 to 128 is enough. Okay, suppose when you want to work with the lot of data set for a big region, then you can use it 120, okay, or 100. You can easily use it. They suggested the random forest number of trees about that. Okay, it means that it creates this type of tree 1, 2, 3 in here only for the 3 tree. But when I use that the 100 number of trees, value is the 100, then it created the total 100 of number of 100 decision tree. Okay, and from that getting the majority voting and get the pixel value about that. It will be water, vegetation, or what happened. Okay, so here you can see the one example, practical example about that. So basically, when you want to lot of classes such as water, urban, agriculture, forest, snow, barren, spares, and this type of classes, lot of classes you need to classify. Then you have to use the random forest classifier. Okay, so basically this is the process about that classification. How we can easily use the different types of classification, random forest, then classification trees. So this is totally theoretical part. So in this time, I hope you can easily understand some topic about that. And after that, I also send you this type of recorded video class, and also send you the PDF. And also I have the PDF reference book also for that. So you can also easily get the lot of things from that support vector machine, then also random forest, then also classification trees. You can easily get the idea. And further, when you can get the idea about that, then you can easily use the Google Earth Engine platform for making the classification. Okay, so this is the very easy way, because in this time Google Earth Engine platform have already created this type of package. Okay, so in this time just we can simply use this type of argument. You can see I simply open my code editor and try to show you that. Just go to the docs tab. So search here classifier. You can see there are a lot of classifier. Yeah, you can see decision tree, support vector machine, minimum distance, classification trees, gradient tree boost. You can see there's a lot of things about the classifier, as well as also random forest, spectral region. Okay, so all of those classifier we can easily use. Okay, because it's a package. Okay, suppose you can see when I click on here, suppose random forest, click on here. So now it will be provide all of those things in here. You can see. Okay, So as a package, so just I define here the number of trees. Yeah, then suppose I put here the 100 or 10, then it can easily make the classifier using the use the 100 number of trees and make the classifier about that. So all of those things we can easily get from here. You can see decision tree. So just open that. Let's clear the decision tree. So now it will be provide the all of the decision tree. Let's see, all of those things we can easily get from here. And also get the train. So this function we also need, because using the classifier we also need to train our model. Okay, so you can see train function. Okay, so this is the basic way about that theoretical part, how we can easily use this. So now in this time I show you the practical example for any how we can easily create the land use land cover classification map using the machine learning. Okay, and then okay, so let's go about that. Just I simply open a code edit, open my code edit and try to show you that all of those things one by one. So I show you the support vector machine algorithm, how it will be work for the support vector machine. So just I simply open my script